Welcome. Let's check out the answers and solutions to this SOL warm-up number 6. Remember that we're going to use some of these as the refresher on our memory and some of them as testing strategy ideas. So in this number 1, which sets are in the form of xy to show me that y is a function of x? So our key word in there that we have to identify is function. So remember, in a function, the x cannot repeat. So if you see repeating x's, then you know that we're going to have an issue with that. So when I look at item A, my x values are -6, 1, and 1. That x value repeats. This cannot be a function. When I look at B, my x values are 7, 7, and 7. Those are all repeats. B cannot be a function. As I look at C, my x values are 0, 0, and 4. Again, I see that repeat. Cannot work. But when we get to D, we've got 1, 2, and 3 for my x's. Those are all different. That is a function because each x value has its own unique y. When you look over at that question number 2, we're going to write the slope-intercept form of an equation for a given slope of 1/2 and a y-intercept of 3. Well, remember, slope-intercept form says y equals mx plus b. That's what you should always be thinking when you encounter slope-intercept form. So we're going to plug that slope value in. 1/2 is going to replace the m. We're going to plug that b value in. Y-intercept replaces b. Everything else about it stays the same. So y equals 1/2 x plus 3 is the equation of our line. Number 3 wants you to solve this equation in order to find out what value of x is going to make it true. So remember that we're going to have to distribute. So this is 3x plus 45. Bring down that minus 6x. And then distribute on the other side, -6x plus 18. We're going to combine like terms so that our 3x and -6x, that's -3x plus 45 equals -6x plus 18. I'm going to go ahead and rewrite that over here just to keep on going since I'm running out of space. -3x plus 45 equals that -6x plus 18. So I want to get all my variables to one side. I'm going to add 6x in order to cancel it on the right, but what you do to one side, you have to do to the other. So now 3x plus 45 is equal to 18. I want to subtract the 45 from each side. So 3x is equal to, do that arithmetic, 18 minus 45 puts us at a -27. And then x equals -9 after we have divided both sides by that coefficient 3. So here we have the value of x that makes the equation true. Now, talking testing strategy here, remember that you also have the access to a graphing calculator when you take your SOL test. So we bring that in here. So if I put in that equation that I am given in number 3, 3 parentheses x plus 15, close those parentheses, minus 6x equals -6 parentheses x minus 3. Right? Okay, there we are. And so where that line crosses the x-axis is my solution. So it crosses at -9, right? I put in x's as my variable, so the x value is my solution. So the -9 from that x-intercept matches the -9 from my solution. So you can always use your graphing calculator to check your work. Okay. Number 4 asks you to find the solution for that system of equations. So you remember that we solved by graphing, by substitution, and by elimination. This one with its x's in a column, y's in a column, and numbers in a column is going to be best for elimination method here. And I see that my y's already have one positive sign, one negative sign, so I'm going to focus then on canceling the y's. Remember that crisscross. The numerical coefficient from the top multiplies to the bottom, numerical coefficient from the bottom multiplies to the top. And so distribute that all the way through then. We get 16x minus 12y equals 40. and distribute our 3 all the way through the bottom. 3x plus 12y equals negative 21. So now we add. So 16x plus 3x makes it 19x for us. Negative 12y plus 12y cancels out, eliminates the y variable just like we wanted. And 40 plus negative 21 makes 19. Divide both sides by my coefficient 19, and x is equal to 1. Now I got to go back and plug that into one of my original equations. I think I'm going to use the bottom. X plus 4y equals negative 7. Seems like some of those numbers might be a little bit easier. So I take the x out, replace it with 1, and now I have to solve for y. Subtract 1 from each side. So 4y equals negative 8. Divide by that 4 coefficient on each. Y equals negative 2. So we put those together to make our ordered pair. X is 1, y is negative 2 for our solution. Again, remember, on that SOL test, you have access to the graphing calculator. So you are more than welcome to type these two equations in and let that help us out as well. 4x minus 3y equals 10 from our top equation goes into its own line. Then the bottom equation, x plus 4y equals negative 7 for my other one. So I type my two equations in on two separate lines. You're looking for the spot where these two lines intersect. Find the intersection point. Feel free to zoom in or zoom out if you need to. And the ordered pair is at 1 comma negative 2, which is exactly what we just found at 1 comma negative 2. The last question here, number 5 on the back, says which scatter plot most likely has the line of best fit represented from this 2x minus 1 equation. So in there, remember that I am looking at a slope of 2. So my slope is a positive 2 over 1. And my y-intercept value from the b is this negative 1. So looking at these graphs, I'm going to find what is probably the line of best fit for each scatter plot, or at least get close to those representations. Okay. And the easier thing for me to look at is the y-intercept. So I'm going to focus on that y-intercept of negative 1 for them. In that option F, does it look like my y-intercept is at negative 1? Well, I'm at 0. Could be a little bit off. Maybe I drew my line a little bit high, so I'm not going to cross it off yet. In G, looking at that, my y-intercept looks like it's between 0 and negative 1, so that could be pretty close. In H, my y-intercept looks like it's all the way down at negative 3. That seems pretty low. Doesn't look like that's going to be a possibility. And then in J, my y-intercept crosses the y-axis there, maybe around positive 1 or positive 2. So that seems like it's too high. We aren't going to want to go for that. So I've got to determine my slope then based on these other two. So my slope is a positive 2 over 1. We're saying rise 2 and run to the right 1. So with that on my graph, could I go up 2 and right 1, up 2 and right 1, up 2 and right 1? And would that keep me pretty much in line with what's going on with that graph? Yeah, it could, because certainly that has a positive slope. That's looking good. When I check out G, I have to go down and then to the right. So that G graph has a negative slope when we clearly had a positive slope in our equation, so we wouldn't select that. Seems like F is the best answer choice here. Hope that you're getting all of these old ideas from our algebra course back into your head as you are studying and preparing for the SOL.